Please continue. Okay, sir. Okay.
Good afternoon, sir, everyone. This is Professor Jay Shankar.
Yes, sir.
I hope my students admitted.
Yes, sir. Thank you,
Huh?
Thank you, sir. Unmute தான் பண்ணிருக்கு. Hello, sir. Can you
Yes, sir.
can you hear my voice, sir?
Yeah, we are hearing.
Okay. And are you able to see the slide, sir, now? Okay. Thank you. Respected the Dean of Science and Humanities, learned members of the Department of Physics and Chemistry and Nanoscience and Technology, respected heads of the department of these three departments, my well-wisher, my good friend, eminent scientist, Dr. Jayasankar sir, C.K. Jayasankar sir from Venkateswara University, Tirupati. Dear professors, dear researchers, dear my students, dear budding scientists, philosophers, I mean young philosophers, ladies and gentlemen, good afternoon and welcome to one and all. I deem it a great pleasure to have involved myself as one among you with this 1 week international conference organized by the Department of Physics, Chemistry and Nanoscience Technology, Periyar Maniammai Science and Technology Institution, Tanjavur. It is my pleasant privilege and priority to express my sincere thanks to one and all. Hello? For having given me an excellent opportunity to join with this program and speak to you on this novel title, Attenuated Total Reflecting Techniques, ATR. A fortune to FTIR spectroscopy for material characterization. This talk may be useful to the researchers who are doing the characterization of the materials on molecular level. Dear friends, I know the difficulties involved in the organization of an event like this. Myself and our Indian Spectrophysics Association, in collaboration with a number of institutions like Periyar Maniammai Institute of Science and Technology. I know my good friend Dr. C.K. Jayasankar sir knows pretty well about the difficulties involved in the organization of a conference like this. Actually, there is one word in English, that is preparation. Preparation is not an English word. This may be a word of human thought. Preparation can be equal to planning plus principle plus practice and patience. Because the preparation is a necessary edge to succeed in an endeavor. You know, 4 wheels of a motor car. Planning, principle, practice, and patience. These 4 can be treated as 4 wheels of a motor car. If these 4 wheels are not synchronized properly and allow the car to run on its own will and wish, just imagine what happens to the fate of the body of the car. But here, these 3 departments combine to the team spirit. Together, everybody achieve more. They have synchronized all these 4 wheels. That's why they have succeeded in this endeavor. Therefore, on behalf of our Indian Spectrophysics Association and my own self as the founder president of the society, on behalf of my good friend Dr. C.K. Jayasankar sir, Professor of Physics, Sri Venkateswara University, Tirupati, I should congratulate the whole team of workers for having organized this kind of activities more effectively, more beautifully in this esteemed institution. I should congratulate Department of Chemistry, Department of Nanoscience Technology, of Periyar Maniammai University. As you know, the title of the talk is Attenuated Total Reflectant Techniques a fortune to FTIR spectroscopy for materials characterization. You see the word that is spectroscopy. As you know pretty well, because I hope that a number of participants joined with this link, maybe PG students or PhD research scholars, including the MPhil scholars. So spectroscopy is that is a colorful word. A colorful word. There is a Vibjaya. Spectroscopy is a beautiful subject which is included as one of the core papers in our PG curriculum, both in MSc Physics program and MSc Chemistry program. And spectroscopy is a wonderful research area because most of the researchers, they are doing their research after synthesis of material. They are going for materials characterization. Then they are going for the applications. For characterization, they are applying a number of techniques, including the molecular spectroscopy, both the infrared spectroscopy and laser Raman spectroscopy. So, Fourier transform infrared spectroscopy, I think, which plays a vital role. One of the powerful tools to characterize the materials on molecular level. On seeing this beautiful word spectroscopy, we have been compelled to recollect, to recognize, remember the services rendered by, the great service rendered by our great philosopher, our father of Indian science, our eminent scientist in the field of physical science, that is a Nobel laureate, our Sir C.V. Raman. The landmark in the history of Tamil Nadu is the birthplace of Sir C.V. Raman. Tiruchirappalli, Srirangam, Thiruvanekkaval. He was the first person and got the Nobel Prize in science from Asian country. He invented Raman effect. He announced this Raman effect, this invention, in the August gathering of eminent scientists all over the world at the Indian Association of Cultivation of Science, Calcutta, on 28/2/1928. That's why we are celebrating National Science Day every year on 28th of February. I consider this. The conference organized by these departments of Maniyar Perima University may be considered as the conference organized in commemoration of the National Science Day celebration. His invention, Raman spectroscopy, Raman effect. He has designed his own instrument. Professor C.K. Jayasekar sir knows pretty well. He is also doing. And a part of his research work using Raman spectroscopy, IR spectroscopy. He has made his own Raman spectrophotometer, not the things imported from abroad, the things available within India. He was able to fabricate a simple Raman spectrophotometer at Indian Association of Cultivation of Science, Calcutta. He has studied the scattering of light in the direction perpendicular to the direction of the incident beam. After the invention of the laser beam in the 1960s, laser gave a great boon to Raman spectroscopy. That's why now we are calling it the laser Raman spectroscopy, then FT Raman spectroscopy. We could not find a leading laboratory in the world without use of the Raman spectroscopy. Unfortunately, there is no any university in our Tamil Nadu chapter in the name of Raman. However, his invention, Raman spectroscopy, Raman effect, So he has fabricated Raman instrument. His invention is more useful for the scientists from the entire cross-section of the world and for material characterization. That's why I have called a very good quotation about Sir C. Raman. Aroma of flowers goes along with the wind, but fame of a scientist goes even against the wind. Dear friends, when you are doing his PG program at the Presidency College, Chennai, with the permission of the professors in the department, to avail the facilities, small optical systems available in the physics laboratory, he made some basic measurements. With that, he was able to publish 2 articles. One is on diffraction at the straight edge. Second paper on surface tension. These 2 papers were published in a reputed journalist in London, Philosophical Magazine, Journal of Science. After having seen these 2 papers, one scientist, a Nobel laureate by name Raleigh, he is from London. He wrote letter to Presidency College, Dear Professor Raman. He was the student of PG student, second year PG program. But he wrote letter, Dear Professor Raman. See the quality of the work undertaken by our Raman. These 2 papers laid a strong foundation to him to do extensive research work in the years to come. So Indian Association of Cultivation of Science, Calcutta, they have published 6 volumes of his articles, research articles. 1 volume on scattering of light. Another volume, acoustics. Optics is the 3rd volume. Optics of minerals and diamonds, another volume. Physics of crystals. Then floral colors and the visual perception. These are all the 6 volumes published by Indian Association of Cultivation and Science, Calcutta. I kindly refer each and every paper published by our Sir C. Raman. I think we'll learn how to publish a paper, how to write a paper, quality paper. I have coined 2 quotations about spectroscopy, about our scientist Sir C. Raman. Forgive a child who is afraid of the darkness. But the real tragedy is when men are afraid of light. But for Sir C. Raman, he is not afraid of light. Because light is his banner. Light is his source. Light is his symbol. That's why this scattering of light, that is Raman scattering, I has done an extensive research work, Raman scattering on materials. Materials may be in liquid phase or gaseous phase or solid phase. Another quotation about spectroscopy, because the present talk is highly focused on one spectroscopy, that is a molecular spectroscopy, that too in specific infrared spectroscopy. Smile is a small curve which makes many things in our life quite straight. Spectroscopy is nothing but a smile. But spectroscopy has many curves, not a small curve, many curves. You refer IR spectroscopy, visual spectroscopy, NMR spectroscopy, which has many curves, many lines, which solves many problems in the field of research. So this is the weightage of spectroscopy. With these few words, my dear friends, let us turn our attention to the present assignment, that is ATR technique, attenuated total reflectance techniques. It is a great fortune to FTIR spectroscopy for materials characterization. You see this slide? Actually, this slide shows the entire cross section of the electromagnetic spectrum. starting from radio wave up to gamma ray, radio wave frequency up to gamma ray. The names of the different regions of the electromagnetic spectrum are expressed here in the order of the range of both wavelengths and frequencies. You come out to the right extreme for shorter wavelength, which has higher frequencies. That means higher energy. And for longer wavelength, and it has lower frequency and lower energy. Dear friends, you see, each and every region of the electromagnetic spectrum, they are classified. That is the radio wave frequency, microwave spectroscopy, infrared, visible, ultraviolet, X-ray and gamma ray. They are classified based on the techniques employed for generation of the waves, for dispersion of the waves, and detection of the waves, based on which only generation, dispersion, detection, based on these aspects only. So these different regions are classified. We are really fortunate. Each and every region will have its own instrumentation technique for material characterization. This is, you are really fortunate. It's a God gift. Each and every region of EM spectrum will have its own instrumentation technique for materials characterization. But our job is now, we are going to give more focus on very small region of the electromagnetic spectrum. That is infrared region. Very small region. You see, you know pretty well about the infrared region is found to be starting from 50 wave number to 12,500 wave number. Because 12,000, we can go up to 12,500, no problem. This is a complete region of the infrared spectrum. So this region is subdivided into three major regions. One is 4,000 to 450 wave number region. This is called the mid-IR spectroscopy. Then far IR region, starting from 50 wave number to up to 450 wave number, far infrared region. 12,500 to 4,000. This is called the near IR region. Dear friends, you know better. Most of the researchers, for their materials characterization, their focus is only on mid-IR spectroscopy, because they are studying on molecular level, mid-IR spectroscopy. Because most of the vibrational transitions occur only in this region, starting from 450 or 400 to maximum 4,000 wave number. Similarly, the far IR region is also equally good, because when you are dealing with the molecules of with heavy metals, even the near IR region, 12,500 to 4,000 wave number is also equally good when you are dealing with combinations and overtone combination, overtone bands and combination bands. But our focus is only on the mid-IR spectroscopy, 450 to 4,000 wave number. You see the slide? Simple way. What is spectroscopy? Spectroscopy is nothing but interaction between the matter and electromagnetic radiation. That is, a spectral line is exhibited when a molecule of a material absorbs a quantum of energy, that is h nu, and goes to an excited state, or a spectral line is exhibited when a molecule in the excited state emits a quantum of energy h nu and coming down to the lower energy level, I mean vibration energy level. So this is a simple definition for spectral line. You see, transitions between two electronic energy levels will give the spectrum in the ultraviolet region or visible region. Ultraviolet means in terms of nanometer, starting from 10 nanometer up to 380 nanometer. Ultraviolet up to 10 nanometer to 190 nanometer, 200 nanometer, that is for ultraviolet. 200 to 380, so that is ultraviolet. Then 382 up to 780, that is the visible region. So the transitions between two electronic levels will give the spectrum in the region either visible or ultraviolet. They are called, that is called electronic spectroscopy. Electronic spectroscopy. In the similar way, transitions between two vibration energy levels within the same electronic level, that is important. That will give a spectrum in the infrared region, that is between 12,500 wave number up to 50 wave number. 50 wave number. You can go up to 10 wave number also. This is called the vibrational spectroscopy or molecular spectroscopy, which includes not only IR spectroscopy, also Raman spectroscopy. And similarly, the transition between two rotation energy levels within the same vibration energy level will give the spectrum in the micro region or far IR region. In far IR region also, which will be a part of the rotation spectroscopy. So they are called rotational spectroscopy or macro spectroscopy. A nucleus or electron. They generate interaction energies. When they are placed in the magnetic field, they are termed as, that is nuclear magnetic resonance or electron spin resonance. So in this way, we can classify, we can give the simple definition for different spectroscopy. As I mentioned, our job is only to focus on infrared spectroscopy, that too within the mid-IR spectroscopy. Quantum mechanically is a simple expression. The electronic energy level, electronic energy can be expressed. That is the vibration energy, vibration energy is expressed using this first equation, that is EV is equal to, that is not EV, V stands for, that is V plus half of H nu naught. Vibrational states, V stands for vibrational states. Takes the value and from V is equal to 0, 1, 2, 3, etc. almost equally spaced. Need not represent the fundamental vibration. H is the Planck's constant. Normally, we are recording the IR spectrum, all other spectra in nanometer, UV visible, fluorescence spectroscopy, everything. But IR spectroscopy, that is a molecular spectroscopy, which is expressed in terms of the wave number. I think you may raise a question at the end, no problem. So to express this energy in terms of wave number, centimeter minus 1, inverse 1, this whole equation is divided by H nu. We are getting, that is epsilon V is equal to V plus half of nu naught bar. That is a wave number in terms of centimeter, centimeter inverse. So vibration energy states V. For lowest energy level, V takes the value 0. Therefore, this is called the epsilon naught 0 is equal to V naught, nu naught complement by 2, nu naught bar by 2. This is called the 0 point energy, 0 point energy. That means even at the lowest energy level, molecules vibrate always. This is the inference we are getting from this 0 point energy expression. Even at the lowest energy level, molecules always vibrate without any radiation. Well, what is the condition for IR absorption? You know, for Raman scattering, there should be a change of polarization, dispersion of the electron clouds of the atoms of the bond. That is Raman spectroscopy. The case of IR spectroscopy, there should be a change in the dipole moment. For example, you take homonuclear diatomics like oxygen molecule, there is no dipole at all. During vibration, in the presence of IR radiation, there will be a change of dipole moment. Hence, homonuclear, there won't be any change in dipole moment. Homonuclear atom, O2. There is no dipole. During vibration, there won't be any change of dipole. Therefore, IR will be inactive. This is a condition for IR. When it is active, you take heteronuclear diatomics, that is HCl, different elements, which has dipole. During vibration, there will be a change in the dipole. Therefore, because of the presence of change of dipole moment, IR absorption takes place. IR is observable only in the heteronuclear diatomic for simplicity, that's all. My dear friends, nowadays, most of the instruments, most of the laboratories in the world, they are using, that is the FTIR spectroscopy, not IR spectroscopy, not conventional IR spectroscopy. Because they are applying, they are using the mathematical tool, that is the Fourier technique. Fourier transform technique is a mathematical tool. Using high-speed computer, they are implementing mathematical tool Fourier transform in the instrumentation fabrication. FTR technique has made significant impact with regard to fast scanning of the sample. Signal to noise ratio is very much high sensitivity and high resolution. These are all the advantages using the Fourier transform technique applied in IR instrument. This is electronics of FTR spectrophotometer. Because PhD students should know, we are studying electronics in our MSc curriculum. Because having the idea of electronics and computer, even mathematics, I think you see for National Science Day Celebration 2002, MHRD has coined one concept, integrated concept in science and technology for a sustainable future. Integrated. You see, I think we can see the integrated approach in this system, how they are fabricating the FTR spectrum, not only FTIR, including Raman and NMR, everything. Radiation source, they are getting the radiation source starting from 452 maximum 4000 wave number with the global source. And you know, the importance of the interferometer, Michelson interferometer. In our MSc laboratory, we are using this small instrument, interferometer, to measure the lambda for the given monochromatic source of light. Even we can measure delta lambda. Lambda 1, 5890, 5896, average is 5893 for sodium. Valence separation. Even for a thin film, we can measure thickness using interferometer. So these are the applications of the Michelson interferometer we use in our PG laboratory. What is the use of this Michelson interferometer in the FTR instrument, which converts the given composite light obtained from the radiation source, global source, into corresponding time domain function. That is the intensity versus time. My dear friends, you are applying the Fourier transform technique using high-speed computer. That is a digital device. Therefore, the output of the interferometer and sample, we are getting only analog signal. Therefore, that should be converted into digital signal using analog to digital conversion. And we are getting digital interference pattern here, which is given as the input of the computer to effect Fourier transform, because digital signal. And the role of Fourier transform mathematics, which will convert the given time domain function into frequency domain function. That is a FT function. That is a digital signal. And before recording, we need output should be the analog voltage. Therefore, we need DAC, digital analog converter. Finally, we are getting the recording of the IR spectrum of the given material. It's a simple way. See, this is the simplest optical path diagram of the FTR spectrophotometer. See the sample compartment. Sample compartment. This is a transmittance sample holder. My dear friends, the present talk focuses only on reflection techniques, not transmittance technique. We are going to replace the transmittance compartment with reflectance accessory, that is the ATR accessory, attenuated total reflectance techniques. But this should be replaced by our ATR accessory. This is the present talk. You see, we should know what is the main difference between the transmission technique and the reflection technique. Most of the laboratory, they are having FTR spectrophotometer with the transmittant techniques. But some laboratories, they got the reflectant techniques. In our lab also at St. Peter's University, we are having the reflection technique only. We are getting the IR spectrum. The samples may be either in a gaseous state or liquid phase or solid phase. We can get the IR spectrum of the sample by means of transmitting IR source through the material. The intensity can be measured in terms of thickness, the concentration, etc. This is the basic concept involved transmission technique. But reflecting techniques, you are using simple methodology, optics, total internal reflection. That is a total internal reflection technique. Simple. I think you are studying this concept in 8th standard school education. So this reflection technique, it combats the most challenging aspects of IR analysis. That is the sample preparation and the spectral reproducibility. Sample preparation is very minimal, very minimal. You must know, before entering the ATR technique, the total reflection technique, let us see what are the issues surrounding our transmitting techniques are that present we are using in most of the laboratory. Initially, long ago, 50 years before, we are using multi technique first for sampling method. We are taking a Nijal oil. Nijal oil means mineral oil, a paraffin oil, few drops. The given sample under test, grinding into a fine powder, mixing with this, this oil to create a paste. This paste is placed in between two KBR pellet. Why are you using KBR pellet? It is transparent to IR radiation. You see the transparent. We are getting almost at 10% transmittance. We are getting horizontal line because there is no absorption at all. Because transmission. K is one element, BR one element. I think there won't be any bond formation between the K and BR. I think there is no bond, means there is no dipole, therefore there is no IR absorption. This is transparent to IR radiation. Okay. Therefore, this cream, this paste is placed or smeared between the two KBR pellet and which is ready to be placed in the sample compartment for IR recording. What is the problem involved in this case? You see, in the mineral oil, Nijal oil, some organic material, which has some bands here. Around 3000 wave number, there are 3 bands. Maybe due to CS stretching vibration. Around 1500 wave number, both bending and symmetric bending and asymmetric bending. And 722, maybe outline deformation vibration. So these unnecessary bands may give some interference to the spectral profile of the tested material. Therefore, it is not admissible. In those days, we are using. At present, most of the laboratories in the country, in the world, they are having Fourier transform, infrared spectroscopy. The sampling method is a KBR method, KBR pellet method. KBR pellet means the sample under test, under investigation, is grinding to a fine powder. You will take around 200 milligrams of powder, the test powder. You will take 2 milligram of our, you will take 200 gram of KBR powder. KBR powder. 2 milligram of our test material, test sample, and mix it together, grinding it to a fine powder, mix together evenly, and which is placed on the barrel having a diameter 1.3 millimeter, and which is transferred to suitable press. Press at around 5 to 7 pascals for 1 or 2 minutes. Recrystallization of the KBr results in clear glassy disc about 1 millimeter thickness, for which you have to spend nearly 25 minutes in the laboratory for sampling method. What are the issues surrounding this KBr pellet? Number 1, complexity of the sample is preparation. Complexity. Very difficult. Weighing 2 mg of test sample, weighing 200 milligrams of our KBr powder, grinding it fine powder. So many things involved. Preparation can be very messy, confused, time consuming. You have to spend at least 25 minutes in the laboratory for sampling alone. I could not expect sample to matter ratio equal in all, because for getting 1.3 millimeter diameter disc with 1 millimeter thickness of the KBr pellet in this small area, we could not expect sample to matter ratio is equal, because homogeneous throughout the sample is not possible. Because for quantitative analysis, there should be homogeneous throughout the sample. Otherwise, we could not get the proper quantification. And the very important thing is, materials involved are fragile. We are spending nearly 25 minutes to get the KBr pellet. Before placing this KBr pellet into the sample compartment, sometimes will be breakable. Materials involved are fragile, breakable, easily breakable. If it is fragile, it means we have to go for second time sampling. You have to spend another 25 minutes, waste of time. And above all, very important problem is highly hydroscopic, because KBr powder is highly hydroscopic. Very good observer for water, because of water moisture present. So in the KBr powder, and because IR radiation absorb water content very easily, therefore we getting broad band at around 3600 wave number due to OS stretching vibration, both symmetric stretching, asymmetric stretching. And we may get another band at 1600 wave number due to H2O bending. For each and every sample, I think by default we can get the water band like this, which may give some interference to the spectral profile of the test material. So these are 8 issues surrounding the KBr pellet. But the present work, the present instrument, ATR technique, attenuated total reflecting techniques, addresses all these 8 issues very easily, very easily. Dear friends, what is the methods you are adopting in ATR technique? Very simple. That is, we are adopting the total internal reflection. Total internal reflection. You see, this is a denser medium. This is a denser medium. This is a rarer medium. Denser medium may be one IRE element, that is internal reflection element, that is maybe diamond crystal or silicon crystal or germanium crystal or zinc selenide, any crystal. But mu will be different. The refractive index of the material will be different. The denser medium will be, it is called, that is IRE element, IRE element, IRE element. And see, in the green shade, that is the sample under investigation. Sample may be in liquid phase or solid phase. You see, sample is placed on this diamond crystal, because in our laboratory, we are having the diamond crystal as IRE element, internal reflectance element. Okay, you see, IR radiation is introduced in the diamond crystal. They are getting the IR radiation from global source, or which is introduced in diamond crystal. A sample is placed on the diamond crystal here. This is the interfaced plane here. Interface plane here. At the point of incidence, because the angle is adjusted, even the people have adjusted the angle of incidence, that should be greater than critical angle. to get the total internal reflection. The angle of incidence of this incident beam is so adjusted so that angle of incidence theta should be greater than the critical angle so that we can get the reflected wave. This is called the total internal reflection. At the point of incidence, an evanescent wave is produced. Evanescent wave is produced above the crystal into the sample for a height of nearly minimum 0.5, maximum 5 micron, 10 power minus 6 meters height. This evanescent wave is called the IR bubble. IR bubble. What is the meaning of evanescent wave? Soon passing out of existence, fraction of a second. My dear friends, the green shade is nothing but the materials under test. This may be in liquid phase or this may be in solid phase. Based on the change of dipole moments present in the molecular structure of the materials, IR absorption takes place. This is a selection rule. IR absorption takes place. Therefore, this IR bubble gets attenuated. Evanescent wave gets attenuated. This attenuated wave is sent back to the reflected wave. With is sent to the, that is a record. We are getting the IR spectrum of the material. The sample preparation minimal. Minimal. You are putting the sample, you are getting the spectrum within 32 seconds. 32 seconds. If you use KBR method, you have to spend at least 25 minutes in the laboratory only for sampling. But in the case of ATR technique, and 32 seconds is more than sufficient. We can get the spectrum immediately. This is the advantage. Sampling is minimal. So the sample compartment, the transmittance compartment is replaced by ATR accessory like this. This is a diamond crystal, simple way. Okay. Here, friends, what are the crystals are being used as IRE crystal in our ATR technique? You see diamond, zinc selenide, silicon, germanium. Normally, people prefer only diamond because of best durability. Chemical inertness. எந்த chemical போட்டாலும் உங்களுக்கு வந்து கரையாது. Best durability, easily they don't scratch. But zinc selenide easily scratches. If crashes occur means we could not get good quality spectrum. That is the problem. Because we prefer only diamond crystal because of the best durability and chemical inertness. Suppose I am dealing with, because you know the refractive index of diamond is 2.4. Suppose I want to test, I want to record the spectrum of one material and which its mu value is more than 2.4. We could not get the reflected wave. We can't get the ATR technique here. Therefore, that should be the denser medium. IRE crystal should have the mu value greater value than the test material. Suppose I want to test rubber material, high density polymer, rubber material. Rubber refractive index 3.8. If you use the IRE crystal as diamond crystal here 2.4 is the rarer medium, but rubber is a denser medium. In this condition, we could not get the total internal reflection. Is not possible. Suppose you are interested to record the IR spectrum of a material like high density polymer, that is a rubber material, rubber industry, and we have to use the German crystal as IRE crystal because mu value for rubber is 3.8. In this way, we have to choose all the 4 crystals. You may raise a question. Diamond is costly, not cost effective. Comparing diamond, zinc selenide, silicon, germanium as a cost effective. Because we are using more frequently. Every day we are recording hundreds of samples using the instrument. I think you are during cleaning the IRE crystal for each and every sample, scratches takes place easily. Therefore, replacement of the crystal is important more frequently. If you consider whole lifetime of the instrument, FTR, ATR instrument, and consider the replacement charge of the ZNSC, silicon, germanium, and diamond is cost effective because there won't be any scratch. This is the best durability and chemical inertness, I think we can use the diamond throughout the life of the instrument. Therefore, you prefer for always the diamond crystal. Cleaning the crystal. Suppose I want to investigate liquid sample. First, clean the crystal. Cleaning is important. Methanol, isopropanol, these are cleaning. You will be getting the background information, that is the air background. Because the crystal is open to, we are not putting any sample for analysis. That is a crystal, diamond crystal is open to atmosphere. The atmosphere, we can collect all air. I think there is air background, which contains oxygen, nitrogen, etc. all gas molecules here. Already, in our instrument, they are given a reference spectrum of pure air. After making subtraction with the reference air background, we'll be getting a straight line passing through 100 T%. That is 100 percentage T. We are getting here parallel to x-axis. There is no spectral profile. That means crystal is clear now. You can go for loading the sample with the IRE crystal now. Therefore, you see, liquid is poured. Whole crystal must be covered quantitatively. The crystal is recessed into a metal plate to return a sample for about 0.2 millimeter height, depth. So, this can be used widely for quantitative analysis. This is the case of liquid sample. What about solid sample? Sample height should not greater than few millimeter. There is some pressure arm here. Pressure arm is here. Should be positioned over the crystal area. Sample is put here. A lot more pressure would need to be applied when analyzing high density polymers and coating on metal surfaces. Because suppose I want to measure, that is the higher spectrum of a crystal. You put the piece of crystal on the diamond crystal here. By using a pressure pour arm, you can give pressure here that will generate, that is high pressure force here. I think there should not be any optical, that is a air gap. In order to get a good optical contact between the test material and the diamond crystal, you have to give the more pressure that is possible, because the crystal size is only 2 mm cross, because area is very small. With limited force, apply on the force arm here, we can generate more amount of pressure here. We can get very good optical contact between the test material and the crystal diamond here. In this way, you can go for the solid material. But a very, very important thing, my dear friends. People are assigning the IR spectrum. You are synthesizing the material. You are recording the IR spectrum of the material. You want to analyze the quality of the material on molecular level, for which you must be thorough with the IR spectroscopy vibrational band assignments. What are called group frequencies? What are called the fingerprint region? What are the internal factors involved? That is atomic mass, thermal resonance, hydrogen bonding, solid state effects, electronic effects, spectral line width, coupled vibrations, physical states, gaseous state, or liquid state, or the solid state, temperature, solvent, and concentration. Also, symmetric and asymmetric vibrations, combination, overtone combination, relative intensity, include degree of depolarization in the case of Raman spectroscopy. So one should be thorough with all these 22 factors here, because if we take solid state effect, correlation field effect, lattice effect, internal modes, external and coupled vibration, so many things are there here. So one should be thorough with nearly 22 factors. They affect the vibrational spectra. Otherwise, we could not assign proper vibrational assignments on the materials you have synthesized. So many papers are available in the literature. They are synthesizing material. They are making assignment with IR spectroscopy, Raman spectroscopy, with improper band assignment, because they are not aware of all these 22 important factors, mainly Fermi resonance, hydrogen bonding, solid state effects, important. I think I need at least 1 hour to complete this one slide alone to make a thorough investigation on the band assignments of a material. Let us have this discussion after some time, a separate lecture. Okay, one should be thorough with interpretation of the vibration spectra in terms of all these 22 parameters, important. Okay, now you are thorough with attenuated, total, reflectant techniques. This is a great boon, a great fortune to FTR spectroscopy by material characterization. You see, I'm going to project some of the basic measurements undertaken by my PhD scholars in our laboratory. All novel application. I take another 10 minutes maximum. Novel applications. Dear friends, you see, this is a comparative spectra of 2 samples of honey. One sample obtained from a commercial source, that is a branded honey. One sample is obtained from pure honey, is a yield station. You see, because the honey has structure is sucrose content, sucrose molecule, which has more number of OH vibrations. I think a broad band, strong band is observed at around the OH vibration 3600 wave number. So, by making a suitable assignments based on all 22 factors involved here, we are able to assign all kinds of vibrations at stretching, symmetric stretching, asymmetric stretching, bending, outer deformation, everything. And from the system, we are able to get best heat of 99.57%, almost 100% heat. You are getting the, because honey being frequently used by pharmaceutical laboratory, honey plays a vital role in making medicines. Therefore, quality of the honey is very, very important thing. Even after making the drug by pharmaceutical industry, before and going for preparation of tablet or injection and a capsule, the sample must be subjected for its investigation using IR spectroscopy on molecular level. Use the structure of the compound, the organic compound, that is a pharmaceutical sample based on structure, and you have to analyze all kinds of vibration frequencies by recording, by scanning the spectrum on different regions, low frequency region, mid frequency region, high frequency, everything actually. So most of the pharmaceutical industry, they have IR spectroscopy to study the quality of the pharmaceutical material, including the game, that is a honey material, important. We come out to next application. What is the role of ATR technique in textile industry? You see, use the cotton, pure cellulose. You take a cotton cloth, the cotton cloth obtained from Cooptex is a cotton cloth. After washing it, after drying, and we are placing the cotton cloth on the IRE crystal. By using the pressure probe, we are giving suitable pressure without any air gap here. We are able to get the spectrum within 32 seconds. That's all over. Because cotton means with the cellulose only. Cellulose. And for pure cellulose, and we have IR library, which is compared with the pure cellulose, and which is found to be 87.97% somewhat impure cotton. So quality of the textile, quality of the cloth could be analyzed more perfectly by using our ATR technique, IR spectroscopy ATR technique. Suppose you are not having ATR technique in your FTR spectroscopy photometer, it is not possible to analyze, to record the IR spectrum of cotton. Because cotton, we can't prepare the KBR pellet, use a fiber, cellulose, we could not get the fine powder. So it's not possible to record the IR spectrum of cotton cloth, cotton material, because of cellulose using conventional FTR spectrophotometer. It is possible only with the ATR technique. Putting the cotton, a piece of cotton here on the diamond crystal, by giving the suitable pressure, we can get the spectrum within 32 seconds. In this way, this can be used in what? the textile industries. Our government of Tamil Nadu, they ban usage of paper cups. Also, banana leaf, banana leaf, paper cup. Even then, most of the events we are using paper cup. The paper cup, paper is made of cellulose only. There is no doubt in it. But for a stiffness, they are putting some coating, wax coating, some coating in the inner surface of the paper cup. You see, upper one is IR spectrum of inner surface of the paper cup, which has two bands here, some bands here, which they are responsible for the polythene sheet. Thin polythene sheet is coated in the inner side of the paper cup, which comes from the polythene sheet. And you see, the outer one, outer bottom, because outer side where some enamel coating is there. Outer bottom, pure cotton. They are getting the cotton material, cotton spectrum, pure cotton spectrum. No, there is no doubt in it. But in the inner side of the paper cup, which is coated with polythene sheet, thin polythene sheet, what happened? You see the temperature, melting temperature of our polythene sheet, maybe 95 degree to and 105 degree. Suppose you are taking beverages, hot beverages at the boiling point, what happens? Is a polythene sheet gets melted. Therefore, you are taking not only caffeine from the tea, you are taking not only caffeine content from coffee, and you are taking also the polythene content, you see, which poses health hazards. Similarly, the paper banana leaf, they serve hot fried chicken, everything, same problem. Top one is polythene coating, bottom one is, as you know, this is a pure cellulose only. Again, which poses health hazard. My dear friends, this is a kind of work undertaken by my research scholar recently, my 75th candidate. So, this is high frequency region. This is called the representative IR spectrum of blood samples obtained from a hypothyroid patient of different days of treatment. Because of the Ayurvedic medicine. Google seed. With the Google seed, they are making a tablet that is the Thyronil. That patient is taking a woman patient having thyroid problem, hypothyroid. She is taking a thyroid, that is a Thyronil sample for about 90 days, one course of period. So these are all the representative IR spectra of the blood samples collected from hypothyroid patient of different days. So there will be dynamic changes in the absorption level for all biomolecules present in the blood. That is the protein, carbohydrate, and lipid levels, also phosphate group, amide, everything. This high frequency region. This is low frequency region. And with that, you are able to get some biomarkers. In analogy with the previous literature, we are able to derive some of the biomarkers from this one. And for one biomarker, as a model example, we have made a graphical representation. Number of treatment along x-axis, and biomarker variation in lipid to protein ratio. That is a biomarker. So finally, initially 0th day, and after completion 19th day, almost approaches the level of the control group, that is a healthy patient group. In this way, you are able to find the efficacy of the drug therapy. So during the after therapy, this is another application in the field of medical physics. Dear friends, another interesting work, very, very interesting work. Any biomolecular changes in the blood with onset of any blood-related diseases, which will reflect other tissues like human hair and human nail and human skin. This is a same concept. You see, this is the morphology of that is our skin. This hair. So skin thickness may be 10 to maximum 40 nanometer, micrometer. And for hair thickness, around minimum 50 to maximum 100 micrometer. So any biomolecular changes present in blood will reflect in other tissues like human hair or human nail or human skin. This is a science concept based on which we can detect. You see, that is efficacy of that is one drug used for that is sugar patient. Sugar patient. Sugar patient means that is a metformin. Metformin. That is a control group. That means a healthy patient. Pre-treatment and post-treatment. This is the average spectra of the IR spectra of the hair samples. We are taking the hair sample, not blood, hair sample from the patient for about 20 patients. For control group, 20 patients. And pre-treatment, 20 patients. Same 20 patients after treatment is over, post-treatment. They are able to compare these three spectra, average spectra. With that, you see, we got some of the biomarkers from the IR spectral profile. With that, this is for before the treatment. After treatment is a control group. So which proves the efficacy of the drug therapy in this way. Similarly, this can be performed not only by human hair, but also human nail. So getting the IR spectrum of human hair, not possible with the KBR pellet method. Getting the IR spectrum of human nail, it is not possible with the KBR pellet method. Getting the IR spectrum of human skin, it is not possible with the KBR pellet method. It is possible with only ATR technique. Dear friends, solid state effects. You see, the crystal is a KDP crystal. You are entering a single lattice. You are taking a single molecule, H2PO4 molecule. And we can analyze, we are recording the IR spectrum. And with that, which has three reference structures. Bipyramidal C2B, polyl one plane C2B, one O above, one O below, again C2B configuration. And with the IR spectral profile obtained from our ATR spectrum, and we are able to study which structure is more stable. I think which confirms the last structure, C2 configuration with one O above the plane, one O below the plane is confirmed because more stable vibration. So in this way, we can study the quality of the crystal material using IR spectroscopy. If you record the IR spectrum of sample using KBR pellet method, so grinding the IR crystal to a fine powder and mixing with KBR pellet takes 25 minutes. When you grinding the crystal means, I think we can't expect the structure may be stable. That is important. So this is one kind. Similarly, this is the kind of work used in dentistry. You see, my dear friends, bulk fill composites have been successfully used in dentistry. Dental composites are expected to have mechanical properties comparable to those of tooth enamel and dentine and provide long life service. So this is the concept involved. So this is the IR spectrum. Uncued bulk composites available in pharmacy. Cued with bulk fill composite, cued with and UV radiation for 10 seconds at the intensity of 600 milliwatts per centimeter square. The below one is cued bulk fill composite treated or irradiated to UV radiation for 10 seconds at the intensity of 850 milliwatts per centimeter square. With this, you are able to get, in analogy with the literature, we are studying the degree of conversion. That is 1 minus the formula here. We are analyzing the polymerization takes place from polymer to monomer. That is the concept here. So here we are going to have got when the DC conversion percentage is 61% here for 10 seconds, 600 milliwatts radiation, and 10 seconds, 850 milliwatts radiation, we are getting 86. But a clinical acceptable value is 55 is more than sufficient. So it is not possible to study this degree of conversion with the KBR pellet method. it is possible to study the degree of conversion using ATR technique. You see, are getting almost 86%, almost the strength, the mechanical strength of density is equal to almost that one. In this way, you see, before filling, after filling, you see the difference between. Hence, ATR technique can be successfully used in dentin also. My dear friends, this is the last slide. Recently, I went to Pugalur, Namakkal district, to observe the activities of making the paper, TNPL paper. They are getting wood material, teak wood, and also other woods here. From wood, they are removing the lignin. After bleaching, they are getting the cellulose. This is the activity I observed in the TNPL industry. With that idea, I assigned a problem to one of my PhD scholars. How we can fabricate, synthesize nanocellulose. The first one is lignocellulose fiber, cellulose fiber. This nanocellulose fiber using the chemical synthesis. So there is a CI, crystallinity index, 898 by 1420. This is a CS2 deformation vibration, asymmetry vibration. This is a scissoring vibration. So with that, we are able to get the factor, that is the value. You see, for LCF, cellulose fiber, and cellulose nanofiber, we are able to get the maximum crystallinity index here. Crystal structure is here. With that material, we have fabricated a material which can be used as a filter in the water purification. This is done also. The nanocellulose fiber is important. We can synthesize a cellulose nanofiber from paper by using some chemical process. That's all. So in this way, we can use our ATR technique in different areas. The faster sampling, no empty sample preparation, improving sample to sample reproducibility, minimizing user to user spectral variation, reliable technique for quantitative studies involving liquids. So these are advantages. My friends, you take performance of a marksman on a rifle range. The first one represents neither accurate nor precise. Second one represents precise but inaccurate. Accurate but imprecise, third one. You see the fourth one, precise and accurate, that is our ATR technique coupled with the FTIR spectroscopy. Suppose you are having the FTIR spectrophotometer with you already, just spending another 3 lakhs rupees alone, we can get the ATR accessory, we can do wonders. This is extremely reliable and well-recognized technique, my dear friends. Therefore, in our laboratory, we are having not only FTR ATR technique, also U-visible DRS DA technique, along with the PLS instrument also for material characterization. Therefore, my dear friends, so this is the 3 annotations signed by our Indian Spectrophysics Association. Concept development for inspiring innovations to bind science and society. Cognitive framework to edifice a sustainable research culture. Cultivation research excellence to enhance innovations and professional developments. So these are the annotations signed by our ISPA to motivate the scholar, to motivate the faculty members in the institution for their professional development. They have to provide quality research work. Quality means, you see, concept development for inspiring innovations to bind science and society means quality, and utility. That is real research. That is a research excellence. The outcome of the research should be useful to the society. That is social application. That is important. You see, what I have shown after my instrumentation technique, the work undertaken by all my research scholars, somewhat societal application. This is real research excellence. Therefore, doing research is as good as doing service to the scientific community. Not only scientific community, also the society. Therefore, you do one thing, you do research, do something useful to the society without expecting anything in turn from the society. That is very important thing. Don't dream about your beauty. It will spoil your duty. But dream about your duty. It makes your life very beauty. Innovations come from creativity. Creativities come from beautiful mind. உலகை பாருங்கள் வியக்கலாம், உழைத்து பாருங்கள் ஜெயிக்கலாம், நினைத்து பாருங்கள் சிந்திக்கலாம், உங்களுக்கு நம்பிக்கை இல்லையா அதோ பாருங்கள் நம் அப்துல் கலாம். Thank you very much. All the best. Any clarifications regarding the ATR technique, regarding the vibrational band assignments of material synthesized? Kindly we invite the questions from the audience. That means you are clear, you understood everything.
Sir.
Hello?
Hello, sir. Good afternoon, sir. It was a
Good
nice
afternoon.
presentation, sir.
Okay.
Yes, I have a doubt, sir.
Okay.
The transmittance percentage you have mentioned here was like less than 100.
Okay.
Yes, but in one article where they have used mesoporous silicon nanoparticles that were coated with chitosan, and there the data had shown the percentage of transmittance is greater than 100. That is 125 something.
Actually,
Yes,
maybe due to the instrumentation problem, because we are giving the light is passed through a substance without any absorptions. I think which is transmitted to the sample means we are getting maximum 100%. That's all. We could not expect more than 100%. Maybe some instrumentation calibration. That's all. Instrument calibration only. The maximum percentage will be 100% if there is no absorption at all. Suppose you KBR, you take KBR crystal. K is one element, Br is one element, and the ions. There won't be any bond formation I mentioned. There is no bond means I think there is no dipole. During vibration, in the presence of IR radiation, and there won't be any change in dipole moment. Therefore, without any IR radiation, IR absorption, again transmitted after the sample, you'll be getting almost 100%. You can't get more than 100%. Means maybe due to some problem in the calibration of the instrument. That's all. Doesn't matter.
Okay, sir. Can we also do that for liquid samples, sir?
Yeah, liquid. By using this ATR technique, I think gaseous state is not possible. Agree with you.
No, sir. To get the percentage of transmittance, can we also do that for liquid samples?
Oh, liquids are not possible because you take liquid, you take which has some molecules which may have some dipole moment change. We can get absorption. We can't get to maximum 100%. Should be less than. Based on the vibrational frequencies or because of the time domain function, no, change it into frequency domain function. We will be getting the vibrational bands maybe less than 100 or close to 100 or 80 or something. Maximum intensity maybe 90 plus. Minimum intensity maybe close to 0. We can't get the maximum 100. Max 100 means when the sample is transparent to the IR radiation, I will be getting 100. We can't get the maximum 100.
Okay, sir.
Yeah.
Thank you.
Nice question. Any other question?
Sir, this is Professor Jayashankar. As usual, your talk is really inspiring. I'm
Sir,
quite sure students get benefited
thank you,
and
sir.
they may come later with their doubts. At
Oh, sir,
present,
sir.
they are able to digest everything.
Oh, sir.
And definitely they will come one fine day and they will contact you, sir. Really very excellent presentation.
Thank you, Professor. Thank you,
And
Professor.
as I suggested earlier,
Oh,
if this recording is kept in the ISPA website,
okay.
people may hit and that will be great for us, sir.
Oh, okay, Professor. Definitely
So
we'll do it.
that you can think of it, sir. That is really very, very helpful.
Oh, okay,
People
Professor.
will, if they have some doubt, they can recheck and they can re-listen your topic.
Okay, Professor.
And that will be highly beneficial, sir. You just think of it.
Oh, thank you,
And
Professor.
particularly, they can think for application side because see, now they know what is ATR.
Okay.
And some people also pose some question when the teacup is having some problem, why government is allowing.
Yeah.
Government is not allowing. When you go to tea shop,
Oh, yeah.
to ask tea in glass, they are ready to serve. Our people also not at all asking.
Yeah.
Even plastic cover, they are banned.
Yeah. Correct.
And they are not practicing.
Yeah.
Similarly, helmet is must for driving.
Yeah.
People are not using the helmet.
Yeah,
So
correct.
all goes the weaknesses of the society.
Yes, sir.
See how long government will fight to wear the helmet?
Yeah.
You can see even today more than 70% youngsters are traveling without helmet.
Yes, sir. Yeah, correct.
So these are the problems that has to come from the mindset of the common people, not from the government.
Yes, sir. You are correct,
See,
sir.
government is having their own industry, they have own politics, they are having own economics.
Oh, sir.
And they don't come on the way. But if you go to tea shop or you ask them, give serve tea in the glass, they're ready to give.
Yes, sir. Yes, sir. Because each and every person, they should have their own responsibility, the important thing, responsibility. Yeah. Thank you, Professor. Thank you. As you mentioned, I think in the ISPA website, we'll give all these aspects.
Yeah, some fundamental lectures. Some fundamental lectures.
Yeah.
Very, very fluent and spontaneous speech. This will help us for application side, sir.
Thank you, Professor. Thank you.
Please.
அந்த ஆல்டரேஷன்ஸ் படி கொஞ்சம் இது பண்ணிருக்கேன் லைக் என்ட்ரி இங்க வந்துட்டு ஒரு என்ட்ரி வந்து ஒரு என்ட்ரியா வச்சுக்க சொல்றாங்க சின்ஸ் அது 9 மீட்டர் ரோடா இருக்கு.
Okay, sir. Okay. So thank you very much for each and every one for their passion. Thanks a lot. Thank you. I thank once again to our Professor George, Dr. George, for having given this opportunity, including the heads of the Department of Physics, Chemistry, and Nanoscience Technology. Thanks a lot. Thank you.
Organizers can close so that everyone will be closed.
Oh, yes, sir. Am I audible, sir? Yeah, yes, sir. Good evening, sir. Yes, sir. Thanks for introduction. Shall I share the screen, sir? Is it visible, sir? Is it in presentation mode? Not in presentation mode. Still, it is not coming. One second, I'll share. Here, I'm in presentation mode only. Okay. Good evening to one and all. I'm Dr. K. Gobi Saranan. So first of all, I'd like to thank organizing committee and the head of the department, Periyar Mani Ministry of Science and Technology, to present my findings. So today we are going to see about some of the research which is going at Center for Nanoscience and Nanotechnology, Satyabama Institute of Science and Technology. So we are doing some related issue for implants. Okay. So we are doing some coatings on implant materials. So from which, so we are doing some biological activities, then mechanical properties, as well as some cytotoxic, as well as electrochemical behavior of bioimplants. Okay. So first, what is meant by biomaterial? From basics first we'll go. So the material which is involved in the biological interaction with the biological material. So that is called biomaterials. Okay. So usually the biomaterials we can treat and augment and repair and replacement of the tissue function in the body. So that is, and also the biomaterial we can use for the diagnostic purpose also. And usually the biomedical devices mainly used for this diagnosis and prevention, monitoring, as well as the treatment of various diseases. Okay, from illness to trauma kind of things. So now we are speaking about the lot of biomaterials like dental implants, then orthopedic, hip replacement, knee replacement, total joint replacement. So now we are speaking not too much of implants now recent days, but the biomaterials it is not a new one. Okay, so already 4,000 years back itself the Chinese and Egyptian, so they have been using for some kind of application like bamboo stick they have used for dental implant application. You see this is, so this is Chinese based the ancient people, so they have used this kind of bamboo sticks. Sir? Yes, sir. Oh, for presentation. Oh, okay. Then the little actually this one only, no, sir, the slideshow. But if I click no, it is not coming. But for my screen it is showing, sir. But there it is not coming, right? Okay, no issues, sir. No issues, sir. Okay. So now this biomaterials is not a new ones. Already some our ancient Egyptian and Chinese people, they have been using for dental applications. So this indicates that they have taken care of their implant material, like dental care and for aesthetic applications also. So now we are using some modern implants like for normal function or speech or aesthetic applications. So we have been using a lot of implants like partial denture and orthodontic wires. So they have been used for our normal modern implants. So what is the need of implants? So now recently the survey is showing that the number of dental implants, the surgery of dental implant surgery is steadily it has increased for the past 45 years. So and also the count nearly 1 million dental implantation has been implanted per year in India. So the implantation, the need of implants, it is growing day by day. So and also the clinical success of the oral implant. So suppose I want to do some implant surgery in oral environment. So that the success of the implant, it is based on the osteointegration, the integration of cells in the nearby implant materials. Okay, so that is the main successful of that integration, that surrounding tissues as well as surrounding environment. So it will since it will play the major role for the success of the implant materials. So in general, so a lot of implant materials are there. First, majorly they are using for metals. What are all the metal they have been using? Stainless steel, cobalt chromium, nickel chromium, titanium alloy, pure titanium, even gold alloy also they have been using. So this material they have been used both orthodontic. Orthodontic means in our oral environment, and orthopedic. Orthopedic means total hip replacement, knee replacement, ankle fracture. So kind of application it is related to the orthopedic. If it is orthodontic, so that is the material used for the dental and the oral environment application. And ceramics also now they are using increasingly using. So what are the ceramics they have been using? Ceramics means aluminum oxide, then zirconium oxide, then yttria doped zirconium oxide. So like that ceramic material also they have been using. So and also the very important thing is they have been using the hydroxyapatite. Hydroxyapatite means calcium phosphate, which is the similar composition to the our bone environment. So the calcium phosphate, using the ceramic 3D printer, they are making this calcium phosphate bone scaffold, then they are doing the implantation. So that calcium phosphate they have been using for cranial application as well as orthodontic applications. Then the metal ceramic. So in order to improve the more mechanical strength, so they have been using for both metal as well as ceramic. So metal ceramic composites to enhance the mechanical property. So these metal ceramic composite mainly used for the load bearing application. For example, this hip replacement as well as knee replacement. So now just we look at the what are all the things will happen so after implantation. So suppose one person has met accident, so he needs to go for some implantation. Okay, so for example, he is going to do some titanium plate on his thigh region. So what are the things will happen after implantation? So first, once we implant the material, first our body fluid it will interact. That means the dissolved ions present in our blood plasma. That means sodium, potassium, calcium, phosphorus, phosphate, then magnesium. So these are all the dissolved ions. First it will interact with our implanted body. Okay, implanted material. Then after that, that protein will adhere. Then protein, the dissolved protein, it will present in the blood plasma, so that will adhere on the ions. Okay, then after that cell will adhere, our body cell. That means osteoblast cells or fibroblast cells. Then after that healing will be taking care. So here, so what are all the things will be going in the negative way? So after actually once the implanted, till the second week, there will be acidic nature will be happening surrounding the implant nature. Okay, so acidic nature means nearly 4.5 to 5.5 or 6. So that pH will be maintaining. And also within 10 days of implantation, there is a lot of possibility to get bacterial infection. That means pseudo bacterial infection. The bacteria it will accumulate and it will invade on the implant materials. Then it will form the colonization. Then after that, implant failure will occur. Okay, majorly the Pseudomonas aeruginosa. Majorly the most of the nearly for 60 to 65% of the bacteria it will colony by the Pseudomonas aeruginosa. So it will form the bacterial biofilm. Then automatically recruitment of immune cells will be there. Then rejection of implants will be there. Then so one disadvantage of for metal implants. So usually now still most of the people they are using for metal implants, but metal implants they have enough mechanical stability as well as some biocompatible property, but it has a poor bonding ability with our cells. Okay, so then after implantation, what will happen? First ions, dissolved ions will form. Then after that protein will adhere. Then after that cells will form on the implant surface. But if it is a metal implant, this kind of activity it will be very slow. But in order to improve that property, so we need some surface modification. Okay, then after that, and also the implantation, that metal implants, it has a very less amount of antimicrobial activity because there is no antimicrobial agent on the metal implants. So in order to improve that, in order to avoid the bacterial invasion, so we need to have some antimicrobial agent like silver or copper, so into that coated on the surface of the implants, so to avoid the bacterial invasion. Though it invade on the implant material, it will die, okay, due to this antimicrobial behavior of the coated surface. So here so the once we call it as ideal implants, the ideal implants, what are all the property should possess? Okay, the ideal implant should possess the enough mechanical strength. So enough mechanical strength means actually the implant material should have the mechanical strength similar to our bone. Okay, it should not have more mechanical strength, otherwise the stress shielding effect will be there. So once we implant, it will break our normal bone. Okay, that mechanical property of the implant, it should be mimicked with the mechanical property of our natural bone, then only the shielding effect won't be there. Then wettability, that mechanical the implant material should be hydrophilic in nature, then only protein absorption, then cells absorption will be easily will occur. Then protein absorption. So what are all the protein will present in our bloodstream? Okay, in bloodstream n number of proteins are there. So once after implantation, n number of protein will adhere on the implant material. Okay, so for example, so suppose if the fibrin protein will adhere on the surface, then it will form the fibrin network, fibrinogen. Then automatically blood clot will be there. Then fibrinogen, then platelets will be there. Platelets will adhere. Then automatically fibrin network will form. Then automatically blood coagulation will be there. Okay. Then in order to avoid, so some bovine serum albumin proteins also is there. If bovine serum albumin protein will adhere on the implant surface, then automatically smoothly will happen. Automatically the cells will adhere. Okay. So that bovine serum albumin protein, it will avoid the formation of fibrin network. So that specifically the protein will adhere onto the implant surface. Then platelet adhesion. So once the platelet adhere onto the implant surface, then after sometimes the platelets will activate. Once the platelet activated, automatically the fibrin network will form, then blood coagulation will be there, then the implant rejection will occur. So in order to avoid that, we should avoid the attachment of platelets. Okay, then cell interaction. So with cell interaction, we have in our body two kind of cell interaction. One is the fibroblast cells, then one is the osteoblast. So for example, mouth environment, so all gingivalists know that this is a fibroblast related growth will be there. So if you take orthopedic application, osteoblast cells will be there. Okay, so if I implant any implant material on dental implant for all in mouth environment, so the fibroblast cells, surrounding cells has to attach on the implant material, so to heal the implant, so surrounding area. Okay, so for example, if we take orthopedic, then osteoblast cells will taking care. I will be taking care to heal the implant related issues. So now in present scenario, so a lot of implant materials coating they are doing. So in order to, as I mentioned earlier, in order to improve the mechanical property, in order to avoid the bacterial invasion, in order to improve the bioactive and biocompatibility, as well as in order to improve the corrosion protection. So for that, we need to do some surface modification. So already some people there, they have been modifying a lot of coating using the titanium nitride. So the titanium Chitra Trivandrum, so they have already commercially available hot wall. Okay, they're made up of the titanium nitride coating. So in order to minimize the platelet adhesion, as well as in order to minimize the growth of the fibroblast overgrowth. And also the hydroxyapatite coating. So hydroxyapatite coating, so actually basically they we have to use for biocompatible purpose. But if you coat hydroxyapatite alone, so since it is a very poor mechanical property, it can easily dissolute after implantation. So in order to avoid people there admixing some kind of metal oxide like zirconium oxide or aluminum oxide or other rare earth material into the hydroxyapatite, then they will coat to improve the mechanical properties. So like that, the alumina also they have been using for knee implants, knee implant material, but it exhibits the very poor fracture toughness. Okay, so due to that, now people they are very lessly using for aluminum oxide. Then zirconium oxide, now the trend is zirconium oxide. A lot of people they are using both orthopedic as well as dental application. Okay, in zirconium oxide itself, no, 3 phases are there. So actually in pure zirconia, it possesses in the monoclinic nature. Okay, if you add small amount of yttrium, that means 4 weight percentage of mole percentage of yttrium into that zirconia, it will become a tetragonal. So if we add 10 mole percentage of yttrium oxide into the zirconium oxide, then we can get cubic nature of zirconium oxide. Okay, but this zirconium oxide, it possesses the very high fracture toughness, as well as mechanical stability will be there. Then corrosion resistance nature will be there. Then since it is a zirconium oxide has itself possesses the antimicrobial activity. So now the people they are using more research is going for zirconia based surface modification for biomedical application. Okay. So then hence but in a lot of research paper, so they have been using so one kind of set of researcher, they are telling that monoclinic zirconia will be more much better than tetragonal as well as cubic. But one set of researcher, they have been telling that tetragonal zirconia, it is giving more prominent result than that of monoclinic as well as cubic. But some other material, they are other researchers, they are telling that cubic is the very best material. So in order to avoid that conclusion, so now we have taken all the 3 material, then we have analyzed all biological as well as corrosion, then mechanical property, then we have finalized some conclusion in which material, in which application it is doing. So like that, so now we have taken as a piece of research. So now we in this presentation, so now we are going to see 3 different phase of zirconia. That means monoclinic zirconia, tetragonal zirconia, cubic zirconia. So we have to coat on the 3 phases of coating on the stainless steel. Then we'll go for mechanical strength, wettability kind of thing. So in order to do the surface modification, so we have this unique system. So this is called electron beam physical vapor deposition. Okay. So here we have a lot of thin film techniques like DC RF magneton sputtering. We have then PLD, pulseless deposition, then thermal evaporation, plasma spray we have. So all among these techniques, so we have taken electron beam evaporation. So in order to achieve the more thickness as well as high adhesion strength. So this is the control unit. So from this we have to control. This is a chamber unit. Okay, here only the deposition will be going on. So this is the power supply. So before that, just we have some basics of thin film. What is a thin film? So thin film is a layer of material ranging from fraction of nanomaterial to several micrometer. So in thin film itself, so we can in film itself we can classify into the 2: thin film as well as thick film. What is mean by thin film? What is mean by thick film? So thin film, if it is less than 1 micrometer, so that we can call it as a thin film. So if it is greater than 1 micrometer, then we can call it as a thick film. Okay. So now these are all the steps I have listed here. So what are the steps will be happening during the deposition? So during the PVD technique. So once the I'll show you this. So once the atom, it will come. This is a substrate. Suppose I want to coat zirconium oxide on the stainless steel substrate. So just to imagine that this is a substrate. So this is the zirconium oxide atoms. Okay, zirconium atoms will first will come, then it will sit on like this. Okay, very smoothly. It will first one by atom will become one by one. Then atom once the sitting is there, then atom will meet each other. Okay, then it is called the doublet. Doublet formation will be there. So then collision and combination. So here collision and combination will be there. Then deposited atom it will meet together. Then after meeting together, the number of clumps of atom it will form as the nucleation. Okay, then after nucleation, then it will come the island growth. Then after island growth, so this is the coalescence. This is the coalescence means this is the combination of island growth. Then will form as the continuous film. So this is a continuous film of zirconium oxide. So like this only it will be deposition will be going on. So now, as I said earlier, so this is now we are going to develop the monoclinic tetragonal and cubic zirconium oxide onto the stainless steel. So this is the medical grade stainless steel. Okay, using the PVD technique, electron beam physical vapor deposition. Then after that, in order to find out the microstructure, roughness, morphology, so we have taken the XRD and some kind of thing. Then mechanical behavior, so we have done some mechanical behavior to which material shows the higher mechanical behavior. Then hemolysis, the hemocompatibility. So which material shows the higher hemocompatible nature. Then we have done some cytotoxic as well as corrosion kind of stuff. So for that, first we need to prepare some substrate preparation. Okay. So actually, unless otherwise it is a smooth film, there won't be much deposition will happen. Yeah. So in order to get smooth film, so we need to clean the surface. Okay. For that, first we need to choose the series of silicon carbide film. So first we need to grind. We need to grind, then in order to make the mirror polished film. Then after we have to clean with the acetone. Then once the cleaned with acetone, then we have to mount in the deposition chamber. Okay. Then after that, so here we have to make the powder material also. The zirconium oxide usually it will be in powder form. Okay. In order to make the compact film, so we need to do pelletizer. In order to make like a tablet kind of thing, we need to pellet. So this is the pellet. So using the pelletizer, we need to make pellet. Then the pellet we have to sinter in 1400 degrees Celsius. So that time all the moisture content will be gone out. Then the pure pellet kind of thing we can get. So in order to make the monoclinic zirconia, so pure zirconium oxide we can take. In order to make the tetragonal zirconia, we need to add 4 mole weight percentage of yttrium oxide into the zirconium oxide. Then we have to mix together. Then we have to pelletizer. Then we have to go for sintering. In order to get the cubic zirconia, we need to add 10 mole weight percentage of yttria into the zirconia. Then we have to go for pelletizer and calcination. Okay. Then finally we will get the tablet like this. So once we get the tablet, so like that is called pellet. Once we so assume actually the evaporation will be going on like this. Okay. So here only we have to mount our source material. So here you see. So this is the crucible. This is a graphite crucible. So here only we are going to mount. We are going to put our the tablet kind. That is a pellet. Pellet we have to put here. Then we have to keep here. So this is a small hole. No, here only the electron will come and it will bombard the. It will fall onto the source material. Okay. So we have to mildly. We have to. Actually we have to give the power. So once we give the power, then electron it will come out, then it will bombard on the source material. Once the source material keep on it is bombarding, the source material it will get heating. Then once the at high power, then the source material will heating, then it will get the liquid nature. Then at the particular temperature it will get vaporized. So that the vaporized molecule it will go and it will deposit on this stainless steel. Okay. So here only it is there. So just you see. So actually here only we have to mount our substrate. So once the evaporation using this here it will go. Here we have mount. Okay. This hole, through this hole it will go and it will deposit here. So this is the rotation. So we can rotate the substrate also. So in order to get the uniform thickness as well as high adhesion strength. Okay. So here the inbuilt substrate heater also we have. So we have given the substrate temperature of 400 degrees Celsius. So in order to improve the adhesion strength of the coating. So here I have mentioned some deposition parameters. So accelerating voltage and base vacuum. So base vacuum usually we keep 3 into 10 to the power of minus 3 millibar. Okay, though actually this source material as well as substrate distance is 25 centimeter. That means 250 mm. So from this, so we have deposited the both monoclinic, tetragonal, and cubic zirconium oxide coating. So after that, we have studied some XRD, then AFM, so in order to microstructure as well as roughness. So here, from SEM it is indicated that the nanostructured film. So this is 200 nanometer scale length. So approximately this particle size is around 20 to 30 nanometer. So from that we can conclude that the nanostructured zirconium oxide. So we have got it. So from this we have made some mechanical properties. So this is the nano indentation. So we have applied the force, the 4000 micronewton. So which is 10% of total thickness. So in order to avoid the substrate effect. So from this study we conclude that the tetragonal zirconia shows the higher mechanical strength than that of monoclinic as well as cubic. Okay. So because of this tetragonal zirconia, it shows the more fracture toughness rather than the monoclinic as well as cubic. Okay. Then this bare substrate shows the very less hardness. Then it is elastic also, elastic nature also. This tetragonal shows the very higher value. Then we did some scratch test, okay, in order to measure the adhesion strength of the film. So we have given the 1 to 10 Newton. The ball kind of thing will be there. So so just you assume that this is a coating. The ball will be go like this, okay, with scratch, okay, with increasing the load. Okay, here you see. So once the material is peel off, then after that the frequency changes will be there. So that will reflect here. For example, so this is the tetragonal, this is a monoclinic, this is a cubic. So this is a monoclinic window. Now if you scratch the monoclinics in 0.5 mm itself, some coating is peeled off. For example, this cubic. So the cubic it is started at 1 mm itself, coating has peeled off. But in tetragonal zirconia, so it shows the nearly 2 mm. It can withstand till 2 mm. Then after that, peeling off will be there. So from this material, from this conclusion, we can conclude that the tetragonal zirconia it shows the higher adhesion strength as well as higher due to the high fracture toughness. It shows the higher better for the scratch test analysis. And this is the tribology. So tribology, what we'll have to do first, if it is the coating surface, just we have to do like this with a stainless steel ball, 2 mm diameter. So with the stainless steel ball, we have to do like this. Accordingly, the graph will come. So what is friction coefficient? So in order to do that, our coating material should have wear resistance for the, especially for load bearing as well as knee application, knee implant application. So in order to do that, so we need the wear resistant nature. So here from this study, so the tetragonal zirconia shows the very less wear value. Rather than the cubic as well as monoclinic. So you see after doing like this, so just we have taken for a SEM analysis, so which material shows the very smooth wear track. So this is a wear track of 3 material, monoclinic zirconia, tetragonal as well as cubic. So from this, the tetragonal zirconia shows a very smooth morphology than that of monoclinic as well as cubic. So this is due to the adhesive wear. Due to it may happen because of the roughness. Okay, so because of the roughness, it shows the higher friction coefficient value rather than the tetragonal zirconia. So from this study, it shows that tetragonal zirconia it is a very stable material for mechanical property. then we need to do some biomineralization study. So for what purpose we have to do biomineralization? Biomineralization means deposition of calcium phosphate based minerals onto the our material. Okay, so usually the biomineralization after implantation, first our minerals only will get deposited on the implants. Okay, the dissolved ions in the blood plasma, it will interact with our implant surface. So for that we need to do the biomineralization study. So if it is more bioactive of our material, more mineralization will occur. So from that we can tell that so this material act as the bioactive nature. So for the better healing or better compatibility or better durability of the implant. So like that we can conclude. So for biomineralization the study, so what we have done is just we take a beaker, then we keep the sample underneath, bottom at the bottom of the beaker. Then we have to pour SBF solution. SBF means simulated body fluid. Okay, so for about 45 days we have taken we have taken this reading. So every 1 day so we have to replace the SBF solution. So what will happen? So during the immersion time, so there's a dissolved ion. So this SBF solution contains sodium chloride, then KCl, then NaCl. Then magnesium phosphate, magnesium sulfate. So these are all the ions it is containing. So that is called simulated body fluid. So during that it will deposit the minerals, deposit on the coated material. Then after that you see that after 1.5 months, so we have taken the same morphology. So you see the lot of lot of grains. So nucleation growth has happened. So this is an uncoated one. This is an uncoated one. So uncoated compared to the uncoated one, so all the coated material shows the lot of nucleation sites. So it indicates that the coated material it should it possesses the bioactive nature than that of the uncoated one. So then after that we have taken the XRD also. So what are all the elements, what are all the minerals has presented in the coated material? So then it shows the calcium phosphate. The calcium phosphate element it shows onto the coated. This is a mineralized sample. So that indicates that the calcite formation has happened on the coated implants. So then hemolysis. The hemolysis, once the implantation has happened, then it should not cleave any blood cells. Okay, so for that we need to do some hemolysis study. So from this hemolysis study, so it shows us the monoclinic zirconia. It shows high hemocompatible nature. But in mechanical side, we have taken the we shown tetragonal zirconia. It shows the very best effect. But in biological point of view, mechanical monoclinic as well as cubic zirconia, it shows the higher level. Okay, in hemolysis, monoclinic zirconia, you see here the value. So this is about 1.49. So what is the hemolysis? The one ratio value is there. So as per the standard value, it should not go beyond 2%. But though this is the uncoated one, this is uncoated. Sorry, here this is uncoated. So these are all the coated material. Okay, so when compared to this uncoated, this is the monoclinic. So the monoclinic it shows the very less value, 1.26. So it shows that the monoclinic zirconia coating shows the very high hemocompatible nature. So then biocompatible. So biocompatibility. So we have tested both fibroblast as well as osteoblast. So in fibroblast, you see the lot of cells proliferation. Can see in the coated materials. In particular, we see the lot of fibroblast. The nature are seen in the monoclinic. Rather than the tetragonal and the cubic nature. So this fibroblast adhesion study indicates that the monoclinic zirconia, it has high potential to proliferate the zirconium, proliferate the fibroblast cells. So this is accredited in orange stain, so but all cells are live. So it indicates that both coated as well as uncoated material, so it possesses the biocompatible nature. But in proliferation wise, monoclinic as well as cubic nature, it shows the high proliferation. Then this is the same mineralization using the osteoblast cells. So once the osteoblast cells grown on the implant surface, once they grown on implant surface, it will precipitate the calcium. Okay, calcium. So automatically, once the proliferation is going on, automatically calcium growth will be there. Then phosphate will come and it will form as the calcium phosphate. That is called new bone. So in so here we have seen that in monoclinic. So this is a red dye, the red kind of thing. It shows the calcium phosphate, calcium crystals. So this is called alizarin red dye. So this is alizarin red dye. So we'll put, so this alizarin red dye will bind with the calcium wherever it is there. So here from this figure, we can show that this alizarin red, the red color, that means monoclinic zirconia, it shows the higher proliferation of osteoblast cells rather than the cubic as well as tetragonal. So it indicates that the monoclinic zirconia, it can capable of high number of proliferation in osteoblast cells too. Then finally, we can come to the corrosion part. So for what purpose we have to do corrosion? So after implantation, a lot of body fluids, some aggressive ions, sodium, potassium, chloride. So these are all these ions, continuously it will bombard on the implant surface. At particular critical condition, so this our body, our implant surface, it will form as the pitting corrosion. Then the leach pitting, if it is a stainless steel, the nickel, chromium, so that ions, it will come and it will deposit, it will mix to the bloodstream, or it will deposit on the surrounding tissues. So that will make the inflammation. Then followed by recruitment of immune cells, then implant rejection will be there. So in order to avoid that, so we need to do some surface modification like the ceramic kind of coating, so in order to improve corrosion protection. Okay, so here we have done both, we have taken the artificial blood plasma, that means our artificial blood plasma as well as artificial saliva. So we have synthesized in the laboratory condition, then we have done the corrosion using that coated as well as uncoated material. So this is the artificial saliva. We have done some instruments. So this is a 3-cell electrode. So this is the biologic workstation. Okay. So here we have used the 3-cell electrodes. One is reference electrode, then counter electrode, then our working electrode. So here we have done artificial saliva. That means AAA means acidulated artificial saliva. So we have made the pH value of 4.5. Okay, in early morning, so once before we brush the teeth, so our saliva will be in acidic condition. So that means around 5.6 like that. So the same mimic we have done. Then with various concentration of sodium fluoride. Sodium fluoride usually it will have in our mouthwashes as well as toothpaste. So with that, what will happen? So in a corrosion condition, this is the thumb rule of corrosion is, so once it goes towards the right side, corrosion happens. So it goes towards the left side, corrosion of protection happens. Okay, this is a thumb rule of potential dynamic polarization. So here you see the uncoated. So it shows the, since it is not towards the right side, so the corrosion happens, but it protects the corrosion. All the coated material that protect the corrosive nature, the protection of corrosion. But here in particular, all the three material, which one is best? This is the tetragonal. So tetragonal zirconia, it shows the more corrosion resistance than that of cubic as well as monoclinic. So from this observation, we can conclude that tetragonal zirconia coating, it protects the corrosion rather than the monoclinic as well as cubic. Then the same we have done with the artificial blood plasma with bovine serum albumin. Okay, but in bovine serum albumin, we have chosen the bovine serum albumin. So in blood plasma, nearly 30 to 35% bovine serum albumin protein will be there, because this bovine serum albumin protein, it will interact always. It will, most of the time, it will interact with our implant system. So for that, in sake of that, so we have taken the artificial blood plasma. Then we have added various concentration of bovine serum albumin into that. Then we have conducted the corrosion. So similarly, it shows the tetragonal zirconia, it shows the higher corrosion resistance rather than the monoclinic cubic as well as uncoated. Okay, so because of this, higher fracture toughness. Higher fracture toughness means actually, if it is very this smooth, this film, it has the very compact film it formed. So due to the compact nature of tetragonal zirconia, it possesses the corrosion resistant nature. And also it reduces the corrosion current. Okay, so compared to the other coatings and uncoated material. So with this, we concluded that the tetragonal zirconia for mechanical property as corrosion resistant property, the tetragonal zirconia is the best material we have found. And for biological application like protein absorption, then platelets and cytotoxic behavior, biomineralization. So that kind of application, monoclinic zirconia, it has shown the very best material. Okay, so from that, we conclude that for mechanical property wise, so if you want to do any mechanical like load bearing application, then tetragonal zirconia will be best. For example, if I want to do some other than load bearing application implants, so we can refer the monoclinic as well as cubic material. So on this occasion, so just I would like to acknowledge my some funding agency. So Indian Space Research, ISRO, Government of India. So where we have been currently we are doing some high temperature corrosion applications. Then Indian Council of Medical Research. So we have sanctioned the project for super hydrophobic coating. Then already we have completed some project with related to implant materials by using the pulse deposition. So in Department of Biotechnology. Then this MHRD project is a spark and related to the University of Technology Sydney. So that is this project is going on for pipeline application for to protect the biofouling. So I acknowledge this funding agency funded by various funding agencies for the Government of India. So thanks for your kind attention. So if you have any doubts, please let me know. I will clarify. Yes, sir. Yes, sir. Yes, substrate is a stainless steel. Then coating is our three material: monoclinic, cubic, and tetragonal zirconium oxide coating. Substrate is stainless steel, medical grade stainless steel we have used. Yeah, conductor. Yeah, actually substrate should be conductor. Then only we can able to perform the corrosion. Okay, any coating, the substrate should be conducting. No. Actually, I have taken the stainless steel. Stainless steel. Yes, I will show you. Can you able to see this? So this is the our material. Okay. So this is a 2 centimeter length and 1 centimeter width. So actually the same kind of dimension we will take. Okay. Actually this is the titanium alloy. So this is a medical grade titanium alloy. So these titanium alloy people they are using for load bearing applications like hip implant as well as knee implant application, as well as endosis application also they are using for the jaw application. The same material we will take on which we will coat. On which we will coat our zirconium oxide coating. Then we have to immerse. Okay. Then we have to mask all those things. Just we have to expose the 1 centimeter by 1 centimeter surface. And then we have to perform the corrosion experiment. Bode, what? Bode plot you were telling? What taffel plot or taffel? Usually for corrosion, actually usually for corrosion, no people they have been using for the taffel plot. Okay, this is a taffel plot. You see, so this one, no, the right side. Right side graph. So that is the taffel plot. Okay, so from the taffel plot only they will see that which material shows the high corrosion protection nature. So which material it shows the higher current. So like that, they will say, they will check from this only. They will take the I car and E car value. So this is called Tafel plot. So from this only we can calculate. Because actually actually titanium, yes, actually, that no, I have taken, so that time the zirconium oxide, people they have been using started now only. So earlier, now aluminum oxide they have been used because of the poor fracture toughness. Then they left that. So now people they are using for whole zirconium oxide as the dental abutment material. And also, a lot of people know, some people they are telling that monoclinic zirconia is better. Then some people they are telling that tetragonal is better, tetragonal zirconium coating. Then some people they are telling that cubic zirconium coating are better. So in order to avoid that confusion, just I have taken all the three material. Then I have done the deep analysis. Then I conclude that for mechanical test, for mechanical application, we can go for tetragonal. For biological application, we can go for monoclinic monoclinic zirconia. Okay, understand, sir? Okay, thank you, thank you. Yes, sir, thank you. Okay, thank you all for your kind attention. So shall I leave, sir? Okay, okay. Thank you, sir.
Good evening to everyone, and I'm very happy to participate to give a special validated address for 1 week international workshop application of nanoscience in the multidisciplinary fields. So, congratulations to the departments, Department of Physics, Chemistry, and the Division of Nanotechnology, that is the Department of Electronics and Communication, EC. So, thank you very much. So, even though we are in the same place, I'm due to some other work, I'm joining in the online. So, as all the students and participants, they know very well, nanotechnology is not a new field. That is, if we do material, prepare a material and use application for in a 10 to the power minus meter, that is a nanotech. We already had piconewton also we have studied, but in between we left nanotechnology, nanometers. That's the only thing. So we understand the materials and the properties in better when we see in nanometer range. So that so we can make a better products. That's the idea. All the workshops, the eminent lectures like Dr. Gobi, we are very happy that he is our alumnus, and he has come all the way and he gave a lecture from Satyabama, and I'm very thankful and very happy. So so I leave this time due to the short time. So thank you very much for giving an opportunity to give the validated address. Thank you, ma'am. Thank you.
Thank you, madam. Is it audible? Can you hear my voice, madam? Oh, thank you. So, on behalf of Faculty of Engineering and Technology and behalf of Management and Department of Chemistry, Division of Nanotechnology, I extend my sincere good evening and greetings to everyone. So, really, it is great pleasure to participate this type of innovative and upcoming field, that is application of nanotechnology in all the field. Particularly in the nanotechnology is very fast growing as well as very important field for the application, and particularly in civil engineering we are very long back using the nanotechnology for coating. During the construction of Rameswaram Bridge, that is Bomban Bridge, we heard about nanotechnology and nanoparticles to cover the surface to protect from the seawater and salt. So nowadays it is growing up. Our city is doing lot of work. I call our party faculty members to conduct this type of seminar or workshop or any event related to nanotechnology frequently, in such a way that our students to participate and gain more knowledge in the nanotechnology, because the application of nanotechnology, particularly nanomaterials. Nanomaterial is essential for all the field, particularly in the lightweight material for the ISRO. It is a very boon for the satellite technology. Similarly, for all the weapons, everywhere the nanotechnology and nanomaterials are applied. So I request all the participants. I hope you enjoyed the entire 1 week session. You gained a lot of knowledge and all of the subject knowledge from the 1 week. Just I request our students to make use of this subject knowledge or nanotechnology or nanoscience for your project. So unless it is no meaning for this type of workshop or conferences, definitely you will do many projects. So for our science and technology, need lot of research science, particularly in the application of innovative materials. So once again I extend my sincere thanks for all the organizers, HOD madam and the physics HOD sir and all the faculty members, particularly the team members who work for this workshop. Also, I express sincere thanks for all the students and participants and the eminent speakers. Here that our alumni students are addressing for this workshop. It is very happy to hear. So I once again I extend sincere thanks to all the opportunity given to me. We are expecting more this type of workshop more and more in the past coming days. Thank you very much.
much.